So a worked example for what we're talking about, pH curves and determining where the vertical portion, the equivalence point will be. The example given is 25 centimeters cubed of HCl at a concentration of 0.1 moles per decimeter cubed, and we're going to add 50 centimeters cubed of NaOH at 0.16 moles per decimeter cubed. So what we'll do is start off with the M1V2. We need to work out the volume of NaOH added to give us the equivalence point. So it's going to be V2 is equal to M1 V1 over M2. If you do that, we'll find that the equivalence of volume is going to be 15.6 centimeters cubed. So now what we can do is plot our axes. This is going to be the volume of NaOH added. We know this is the one that's added because it's the greater volume. We're also going to monitor the pH. It's going to potentially go from a range of 0 to 15. Usually this goes from 0 to 50 at the bottom. We know that at 15.6 there's going to be a radical change in pH. So there's 25, 15.6 is going to be about here. So next point is we need to have a look at what we are starting with, which is HCl, strong acid. So we're going to be starting off a pH of about 1. We're going to see very little change. We're going to see a buffering action occurring, very little change in the pH as we add the NaOH, but then all of a sudden we'll see a radical change, a big step up, a curve up like that, and it will continue upward. And then we need to have a look to see what we're titrating with. In this case it's NaOH, which is a strong base. On an excess amount of NaOH we're going to end up with a pH of about 13. So by the time we're here it'll be about 13, so we need to go all the way back to here and then a curve down at the equivalence point, and then we've got this vertical portion here. So this here is going to be our equivalence volume. We can extrapolate forwards, we can extrapolate back, we can take a vertical section, half that value, and we'll see that the pH at the equivalence point for a strong acid, strong base is 7. And that's how you go about drawing pH curves. You will need to be able to construct pH curves like this for every possible combination of strong acid and weak base, strong acid, strong base, weak acid, and everything in between.